Alright, so question 2a, reaction of an unsaturated carboxylic acid with hydrochloric acid yields compound K and L as shown below. So here we have our reactant J. Okay, so it has a carbon-carbon double bond, okay, because it's unsaturated as well. And we have our carboxylic acid. So here we have our carboxyl group reacting with HCl. Okay, so for Roman 1, draw the structures of K and L. Okay, so we want to know what products that you will form. Okay, you have two products. So you need to recall, okay, does alkene react with HCl? Okay, does carboxylic acid react with HCl? Okay, so if you remember, carboxyl group, it does not react with HCl, but it reacts with PCl5 if you want to substitute the OH with any Cl atoms. Okay, so for alkene, it will react with HCl. Okay, so if you look closely as well, your alkene has two hydrogen atoms, two different environments. All right, so you will be getting two products. Okay, so this is your first and second product, K and L. All right, and then number 2, which product is more acidic? And give your reason. So acidity, okay, depends on the ability of your compound to release its H+. So these two, okay, products, okay, it has different position of the Cl atom. Alright, so you should know that your Cl atom is an electron donating group, right? Electron withdrawing group. Okay, so it is very electronegative. That means that it's going to pull your electron density to itself, okay, to the Cl atom. So that makes your oxygen here, okay, bila dia ionize, dia ada negative charge kan? Okay, so which oxygen is higher in electron density? This one, number 1 or number 2? So obviously it will be your number 2, right? So this one here will have more electron density at the oxygen. That means that it is more acidic than this first product. Okay, because this one, the position of your electron withdrawing group is closer to the carboxylate ion. Okay, so more electron density is being pulled, or it has a stronger inductive effect, okay, which makes this one less acidic than this one, the one with the electron withdrawing group further from the carboxyl group. Okay, so you need to write your explanation lah. Okay, electron withdrawing group and inductive effect. Next, Roman 3, predict the product formed when J reacts with potassium metal. So here J, okay, you need to see what functional groups you have. You have carbon-carbon double bond and carboxyl group. So which one will react with an electropositive metal? Okay. Alright, next question is number 3. Arrange the following compounds in ascending order. Ascending order meaning from small to big. And your symbol, okay, when you are writing down the sequence should be like this, from small to big. Okay, ini yang small, okay, this one is big because this one is wider, right? Okay, so boiling point, we will be talking about intermolecular forces. Okay, so what you need to do is you need to draw out your compounds. Okay, because sometimes if you don't draw your compounds, you will mistaken their functional groups present. Okay, so what I want you to do is to draw. Okay, so let's look at the answers. Okay, for question number 2. So this is question number 2 punya answers. Okay, so this is the kind of explanation that you should have. Alright, and this is the answer for number 3. Okay, and then this is the third question. Okay, arranging in ascending order of boiling points. So I want you to draw your structure. Okay, so kalau awak tersalah, then you could have thought that this was an alcohol. Okay, but this is actually an aldehyde. Alright, this is carboxylic acid and this is your alcohol. Okay, so when you draw, okay, you ensure that you don't make any mistakes of the functional group. So determine the functional group. Okay, present. Okay, is it a polar molecule or non-polar molecule? And then you want to determine the intermolecular forces. Alright, so obviously carboxylic acid can form hydrogen bonded dimers with itself. Alright, so alcohol, you have OH, so you can form hydrogen bonds. Alright, so aldehyde, it is a polar molecule. It cannot form any hydrogen bonds, okay, but it can form dipole-dipole attraction. Okay, so this is the answers for number 3.